Let's first take a look at solving exponential equations. Here are the two approaches we're going to take. Try rewriting using the same base, and if that doesn't work, take the log of both sides. So let's take a look at this problem. A to the x is equal to 2 to the x plus 6. We're looking for the value of x, which would make this equation true. So notice that on the left-hand side, on the right-hand side, I have an 8 as a base and 2 as a base. And I could rewrite 8 as 2 cubed, right? Because 2 cubed is 8. And then on the right-hand side, I have 2 to the x plus 6. So notice here, using the power property, I'm going to have 2 to the 3x equals 2 to the x plus 6. So if I have 2 to the something equals 2 to the something, those two somethings must equal each other, right? It's a one-to-one property there. So now I can just go ahead and solve, subtract x on both sides, and x equals 3 as your final answer. So here's another example. 5 to the x minus 2 equals 200. So notice I have base 5 here, and we want to ask ourselves, is there a way that I could rewrite 200 using the same base, base 5? And the answer is no. So once you've isolated the exponential part, it's just 5 to the x minus 2, we can take the log of both sides. I'm going to take the log of both sides. And remember, I can take the log of both sides using whichever base I want. But the base that I want to use is base 5. And I want to use base 5 because right here, when I have log base 5 and 5 to the something, these are inverses of each other, so they're going to cancel out. They undo each other. So these are going to cancel out, leaving me with just x minus 2 on the left-hand side. And on the right-hand side, I have log base 5 of 200. And so x is equal to 2 plus log base 5 of 200. So if it's a non-calculator part, you would just leave your answer this way. Since log base 5 of 200, we cannot simplify further. If it's a calculator part, you would plug into your calculator, ending up with 5.292 when rounded to the nearest thousandths, or 3 decimal places. All right, here's another example. 9 to the 8 minus x equals 27 to the x minus 3. So we want to ask ourselves, could I rewrite the 9 and the 27 using the same base? And the answer is yes, if you use base 3. So 9 is the same thing as 3 squared, and 27 is 3 cubed. Note here, when I have a power property, I'm going to distribute the power because it's 3 times the quantity x minus 3. So I end up with 3 to the 16 minus 2x equals 3 to the 3x minus 9. Because I have 3 to the something equals 3 to the something, that's a one-to-one setup. And therefore, I can set those two somethings equal to each other. You could also think of it as taking the log of both sides at this point if you'd like, with base 3, and these would cancel out, giving you 16 minus 2x equals 3x minus 9. And if I solve for the value of x by adding 2x to the other side, adding 9, and dividing by 5 here, I end up with x equals 5 as our final solution. Here's another example. 7 to the negative x equals 21. Is there a way that I could rewrite 7 and 21 using the same base? And the answer is no, right? 21, I can't rewrite that as 7 multiplied by itself as number of times. So I'm going to have to take the log of both sides here. And the base I'm going to use is base 7 because I'm trying to get this exponent down to the regular level here. These cancel out. I get negative x equals log base 7 of 21. Divide both sides by negative 1, right, or multiply by negative 1, and x equals negative log base 7 of 21. That would be your final answer in a non-calculator portion. If it's a calculator portion, you would type it in, and rounding to 3 decimal places, you would get 1.565. Note that if it's a calculator portion, you can check your answers fairly easily, right? You do 7 to the negative 1.565 power, and you should get about 21. Now let's take a look at solving logarithmic equations. So for logarithmic equations, you need to check for extraneous solutions. Whatever your answer is, if you plug it back into the original equation, it must make your argument be positive. So again, for example, the argument is everything inside of the logarithm, right? What were two squirrels doing inside of a log? They were having an argument, right? The inside, if it's not positive, this is undefined, so it wouldn't actually give you a solution, right? So when solving logarithmic equations, make sure you, at the end, check that all of your arguments are positive. So the plan for solving logarithmic equations is as follows. You're going to exponentiate both sides. Sometimes you may need to condense and then exponentiate both sides. Here's an example. Log base 6 of 3x minus 10 equals log base 6 of 14 minus 5x. We want to solve for the value of x that would make this statement true. So one thing you can notice is I can exponentiate both sides. And so the 6's, right, 6 and log base 6, they cancel each other. We get 3x minus 10 on the left-hand side and 14 minus 5x on the right-hand side, and we can solve. You technically didn't need to exponentiate on both sides for these because the way it's set up, it's a 1-to-1 property, right? Log base 6 of something is equal to log base 6 of something. Therefore, the two somethings must equal each other. However you want to think about it, it's fine for this particular setup. Okay, when I solve for the value of x by adding 5x and then adding 10 on both sides and then dividing by 8, I get x equals 3. But that is actually not your final answer, because remember, you have to check to make sure that your answer makes sense. Whatever the original equation is, before you did anything to it, you will need to check that the argument is positive in value. Because it's not positive, you're going to get undefined, right? So let's say if I plug in 3 into the original here. So that's 3 times 3, which is 9 minus 10. Do you see how that gives me -1? This whole thing would be undefined. So if it fails one of the logarithms, it's automatically out. So I already know this doesn't work. So my answer would be no solution. But let's go ahead and check the other one, see if the other one checks out. So that's 14 minus 5 times 3, so that would be 15. That would also give me undefined as well. Okay, so it's no solution because you get undefined. Again, once one of them checks out, such that the argument is non-positive, then that solution is automatically extraneous and it doesn't work, so you have to toss it. Again, final answer for this problem, no solution. All right, log base 3 of x minus 5 equals 2. What value of x would make this statement true? So we can exponentiate both sides. And so we end up with x minus 5 equals 3 squared, which is 9. And then x is equal to 14. So real quick checking, 14 minus 5, that gives me a positive value for my argument, so we know that this answer is good. Some of you may prefer to think of it as rewriting the log as an exponential form. So if you wanted to think of it as 3 squared equals x minus 5 as an equivalent statement, so 9 equals x minus 5 and x equaling 14, that is also another way that you can go about it. But I find that most students find it easier exponentiating both sides with the base, with the same base that would cancel out the logs.